Okay, so in this tutorial I'm going to show you how to set up an internal receiver to do some calculations too. At this point I've already loaded in some internal surface finishes, and I've also loaded in an internal criteria object. There are separate tutorials on both of those things. So the first thing we need to do is go to the data tab and click on the internal receivers box, and now this will bring up this dialog here. It's got some additional information you can see there in the list of receivers, but we'll come to that in a bit. So if we click on add receiver, it'll open up a new internal receiver location. So the internal receiver dialog box is a little bit more complicated than the noise sources box. It gives us additional panels for entering in information about room geometry, room acoustics and noise levels. Okay, so let's give this a reference, so we'll just call it GF01 and we'll say it's a classroom, for example. And I'm going to select from the criteria type BB93 and primary school classroom. Like I said, I've loaded in the internal criteria object already. That's how I'm able to do that, and there is a separate tutorial on doing that. Okay, so having selected that as a room type, you can see now the room acoustics and noise levels panels now have maximum room acoustics criteria and noise level criteria. Okay, so if we hide both of those, so let's put in the room geometry. So you can either use the simple calculator for putting in room geometry, or you can use the you can just write it in manually. It just needs to know the volume and surface area in order to carry out the room acoustics calculations. So if we say we've got a rectangular room, there is also cylindrical and there's also non-specific, so you can take the perimeter and floor area directly out of AutoCAD, which you can measure using the area tool. So if we go back to rectangular, ceiling shapes, there's flat, pitched, pyramid and sloped. So let's take a sloped ceiling room. We'll say the height of the main room part is let's say 2.8 meters. It's 8 meters long and 7 meters wide, and we'll say that the ceiling part of it is 1 meter high. So that's that, the room geometry. So let's put in the room acoustics information. In this panel here, you can choose to either use a calculator, which will build up the different materials in the room and calculate your alpha bar for you. Or you can just write in the alpha bar yourself if you've calculated it elsewhere. You can also just put the rev time in directly as well if you want to, and then it will calculate the alpha bar for you based on the room geometry information that you've put in. If you use the reverberation time calculator part of it, you can choose whether it uses Sabine or Airing to calculate the reverberation time. You can choose whether you include air absorption or not, and if you do use air absorption, then you have to enter a humidity in there. Okay, so if I show the calculator again, like I said, I've already loaded in some surface finishes. So if I add a material into this room, I can link it to one of the materials I've loaded in already. So let's click floor finish 1 and we'll call it floor carpet. And so you can see it's loaded in the absorption coefficients for the carpet that I've put in the surface finishes area. And we can also link that to an area in the room because we're using the room geometry calculator. So if we say that it's on the floor, and we can say it's 70% of the floor, for example, and it will work out the area there for us. So if we click OK, that will be added into the room. Let's add in another floor finish, so we'll link that to a different material, so we'll call that one floor vinyl. So that's a vinyl part of the floor. Again, the absorption coefficients have been loaded in, and we can link it to the floor again and we'll say it's 30%. And finally, let's put a material on the ceiling, so we'll link to material. I've got one there which is some perforated plaster tile, so let's just call that ceiling, and we'll link it to the underside of the sloped part of the ceiling. Okay, so you can see now that it's basically added in those three materials, and it's calculated the reverberation time for us, and you can see there at the bottom the comparison. It's comparing the reverberation time that we're calculating with the criteria, so you can see we're kind of over at the lower frequencies and we're okay in the mid frequencies. That's pretty much the calculator. You can make different surfaces active or inactive if you want to see what effect they're having on the overall reverberation time, but otherwise it's pretty straightforward. So that's the room geometry and room acoustics. The noise levels part of it, the way you get noise into the room is by plugging noise levels into an internal receiver component on the canvas. So let's just go and do that now quickly. So if I bring on an internal receiver, there's an internal receiver noise component. There are internal receiver geometry components and room acoustics components for bringing different information about the internal receiver onto the canvas, but just for the purposes of this we'll concentrate on the noise component. So if we select our room from the internal receiver noise, and this is the noise source that I created in the noise source tutorial, I'm just going to plug that directly in. Obviously if you were doing this properly you would need to put in corrections along the way to show your any mitigation from the noise source going into the receiver room, but just for the purposes of this tutorial I'm just going to plug it in directly into the direct field node there. So if we open up that receiver again now, you can see from the receivers box here, it's showing the 500 Hz reverberation time that it's calculated. It's showing what the max reverberation time is there. It's also showing what the noise level is in the room now, which is 68 dBA because we've plugged that source into it, and it's showing that the max noise criteria is 35. So if we open that up, we can see there that noise levels are being shown, and obviously we're some way over the criteria. But the only other point to make is that I've plugged the noise source there into the direct field node that you can see, and there's a reverberant field node as well, but those are purely for convenience to allow you to distinguish between parts that you want to identify as direct field and reverberant field. The program itself won't do any room acoustics corrections for you, because there are different room acoustics corrections depending on where the source originates, whether it's inside the room and outside the room and that kind of thing. So it can't make those assumptions for you, so you need to do the room acoustics corrections yourself before plugging the kind of the resultant reverberant LP rev into the node. The other thing you can do in the internal receiver as well is, like with the surfaces, you can make them active or inactive to see what effect they're having on the room, and you can also change the quantity of them if you wanted to see, for example, how many of a certain type of noise source you could have before it breached the criteria. So that's pretty much for the internal receivers, and I'll do a tutorial next on the external receivers.